Section 3.4. The last time we have mentioned the derivative of a sum of functions. If you have to take the derivative of two things added up, all you have to do is take the derivative of each one and then add them together. Now, what about the derivative of products? Say if you have two function f times function g, what would be the derivative b? Well, the most direct thing you can think of is maybe just take the derivative of each one and multiply them together. But that doesn't work because the way the fraction works in the definition of the derivative. So it doesn't work, and as a result, we have to figure out another way to see if there's a quick formula that can calculate the product derivative of products. So we have to go by the original definition. Let's say you have to take the derivative of f and g. Okay, so df by, this is by dx of fx plus gx, that, not plus, why did I say plus? It's multiply fx times gx. We're trying to figure out the product. To do that, we have to go back to the original definition of the derivative, which is that limit thing. The limit as t goes to a of ft gt minus fa ga over t minus a, and that is the definition of the derivative of anything. Okay, you take that function at value t minus the function at value a over t minus a and take the limit as t approach a. Okay, now we're kind of stuck here. So this part, you're not going to be able to split this into any two fractions to like the way you would do with the addition formula anytime soon. However, so what we're going to do is pull a certain trick. And the trick will allow us to split it up to make it look like derivatives of each, and then everything will come out very nicely. So here's the trick. So this equal to the limit. What we're going to do is we'll write down the original thing. Here's ft gt as t approach a, but I'm not going to write that to save some time. And what we're going to do is we're going to subtract f a gt and then add it back in again, f a, exact same thing, gt. So in doing this, we're minus f a gt plus f a gt, which means that we add a 0. And so the equation still holds. And we continue to do this and write down the rest of it, f a g a. And the whole thing, of course, is over t minus a as taking the limit as t approach a. The reason we do this minus and then the plus trick is so that we can split everything into two chunks, which now it will look better and be able to handle it better. So right now, look at the first part. There's gt that's in common, so we'll take the gt out. So this equals to the limit gt, and then what we have left is ft minus fa over t minus a. And as you can see, this thing is f prime of at a. This is the very definition as you take the limit. And that's why we're doing this. And then splitting this into two chunks. Actually, this should be a minus. Why do I have a plus here? I think this should be a minus right here. So it should be a minus. Anyway, so we have, and the next part, we will have, we'll split, because it's a fraction, we'll split it into two fractions. And the limit, and the last two chunks has fa as the common factor. So we'll factor it out. And what's left is gt minus ga divided by t minus a. So by subtracting and adding this particular thing, which we have not changed the value, but we are now able to split this thing into two chunks, for which it will be easy to take the limit. Because as t goes to a of these limits, both sides we're still doing t goes to a. As t goes to a, this value becomes ga, since t is going to a, right here. And then this is, of course, f prime of a. That's the very definition as you take the limit. So that equals f prime of a plus And this side, that's just FA. As t goes to A, FA is still FA because it's a constant for the limit. So that's FA times this thing right here is G prime of A as the limit, as you take the limit. So this becomes G prime of A, and that becomes the result of our the taking the derivative of a product. So when you take the derivative of a product, what you end up doing is you take the derivative of the first term times the second value plus the derivative of the second term plus the first value. Or put it another way of saying it, the save on some symbols, is the derivative of u times v. Okay, if you were to take the derivative, what you do is you will be u prime v plus v prime u. See, the derivative of the first times the second plus the derivative of the second times first, and that's how you do the derivative of a product of two things multiplied together. Now, let's look at some simple examples. For example, let's say we have to take the derivative of something such as let kx equals to x sine x. What is the derivative k of x? Like this. So k is a function that's just simply x times sine x. What is the derivative of k? Well, the derivative of k, so k prime of x, is equal to, following this rule right here and remembering how to take the derivative of various things, the derivative of the first term, which is just 1, times sine x, plus the derivative of the second term, which is cosine x, times the first term, which is x. And that is the answer of the product. And then let's see. Okay, let's look at, say, a different problem. Suppose another problem, let's say, is slightly more complicated. Let's say we have a k equal to x squared times sine x cosine x. So now you have 1, 2, 3 things to multiply together. Now, and whereas the product rule only has 2 things. To do that, what you do is you calculate 2 chunks of them at a time. So we still use the product rule, like exactly like this. But what we're going to do is we will say so k, this is k of x. So k prime of x, we'll just call it 2 chunks, even though there's actually 3 things here. We'll call it 2. We'll say the derivative of the first, which is 2x, okay, times the second thing. We'll call this whole thing as 1 chunk. This is a chunk, and that is a chunk. So we'll take the derivative first, which is 2x, as from this rule here, okay, nx n minus 1. So 2x to the power 1. And then times the thing of second, plus the derivative of the second, we'll just write it down like this. The derivative of the second, sine x cosine x, take the derivative, and times the value of the first, which is x squared. All right, so the next question we have is, what is the derivative of sine x cosine x? So then we'll do it separately right here. So the derivative of sine x cosine x, which has just 2 terms, okay? And we will use the product rule right here, which is the derivative of the first term, which is the derivative of sine is cosine. So that it becomes cosine x times the second term, and then plus the derivative of the second term, which is minus sine x, times the first term, okay, v prime u. U is sine x, which is the same as cosine squared x minus sine squared x. And then we plug this value in here, and that will give us the derivative of that whole thing. So you just will copy the whole thing down, which is going from here So k prime of x equal to 2x times sine x cosine x plus, well, plus the derivative here, which is this thing, cosine squared x minus sine squared x times x squared. We'll write x squared over here. And that is the answer to the derivative of this. So as you can see, when you have more terms, then you get it, the whole thing gets more complicated, but the principle is the same. You just identify one chunk as the first and take the derivative second, and then take the derivative what's in there and keep working into an inner and deeper layer until you get everything worked out.